Hello everyone and welcome to this another episode of 3D prototyping in Unity. My name is Kasanas. In the last episode we were still working away on our zombie and we're not doing too bad now. We've got our zombie set up so we can now shoot it and kill it and set it on fire and all that kind of good stuff. We don't actually have the ragdoll physics or anything like that set up yet. That's going to come in a future episode. Today, I'd like to take a look at creating the actual detection and the movement of the zombie. Alright, let's get started. Okay everyone, today is another code-heavy day, unfortunately. For those who don't like code, it's definitely a long code-heavy day. Today we're writing the code that's going to be controlling this zombie almost completely, right from its idle state, from the very beginning, right from its idle state, all the way through the detected and running state. Now basically how we want this zombie to work. We want these zombies to be instantiated facing one of two directions, either left or right. They're not going to flip afterwards, but they will have an idle animation that will constantly be going off, and the idle animation will run nice and smoothly. After that, what we want to do is we want to be able to detect the player. If the player walks within the detection zone, so this aggression zone that we already set up on the zombie detection node, if the player walks anywhere within here, we want the zombie to spring out of its idle mode and start walking towards the player. And once it's been walking for a certain amount of time, we want the zombie to start running. Alright? And if the player leaves the detection zone, then we can start to walk again. The zombie will start walking again if the player leaves the detection zone. But it will not stop. The zombie will not stop until after the player is either dead, has killed the zombie, or the zombie has fallen off the edge of the screen. That's our big plan. We're also going to have this script take care of a couple of other things. We want something more than just the idle of the zombie. We're going to have a number of audio clips that can be played that will kind of like give a little bit of randomness to the zombie noises and the noise of the background and that kind of stuff. That's really what we want to do. Now, there's going to be a lot of code here. I don't think we haven't set up the animation yet either. So we're going to set up the animation today and we're going to set up the code. Alright, so I think first of all we'll start off by setting up our animation state machine. Basically we're going to put it up here in our animator. And our animator is currently located on the top level of our zombie. So let's switch over to our animation prefab, or excuse me, our animation folder. And I'm going to just say create, and I'm going to create an animation controller. And I'm going to call this zombie AC. Alright, zombie animation controller. And I'm going to take that and I'm going to pop it right into this controller here, this controller slot on my animator. Now this is going to allow me to drag and drop my animations that I've currently got for the zombie already set up. Let's go in and take a look at our model. And let's take a look at our zombie. And here we go. Here's our animations. And what I'm going to do is I'm going to go to my animator screen and I'm just going to drag the idle, and the run, and the walk. That's all I'm really going to be using. I'm going to drag and drop them right here. And the zombie idle is going to be my default state, so that's great. My zombie's going to kick in, and he's just going to be kind of moving slightly. I don't want a whole lot of movement here. It's just a slight movement. And like I said, all of these animations were already created previously inside of a 3D package. All right? Now, what I want to happen is once my character is detected, I want my zombie to go from idle to run. So I'm going to make, idle to walk. So I'm going to make a transition like this. After that, what I want to do is I want to have my zombie be able to go to the run state. After a certain amount of time, the zombie will automatically go into the run state. After that, the zombie can go back to the walk state if the player leaves the aggression zone. It's not going to stop moving, and it's never going to go back to the idle state. Alright, so I'm just going to make a transition that goes from run to walk. Okay, that's great. Now, there's a couple of things that we need in here. We're going to need a parameter. The first one we're going to have is we're going to have a boolean. And this boolean is going to be, we'll call it detected. Detected. Alright, and the detected state, once the player enters the aggression zone, they're going to be detected. So we're going to start off with detection equal to false. But if our player comes into our aggression zone, we want to move from the detected state well, when it's true, into the zombie walk. Perfect. That's exactly what I want right there. All right, so from the idle into the walk. Okay, now the next thing I want to be able to do is go from the walk to the run. And once again, I'm going to add a parameter in here. I'm going to click the plus sign. I'm going to add a trigger, and I'm just going to call this run. All right, and if we trigger the run, the zombie will automatically go from the walk to the run. So let's plus this up, and we will switch this to run. And lastly, let's just shrink this down a bit. We'll kind of go nice and quick. Lastly, what I want to do is I want to move from the run state back to the walk. And once again, all I'm going to do is base it on the actual trigger, all right? The actual trigger occurring. So if the run trigger goes off, then once again, our zombie is going to move back into this state. And let's just remove the exit times. We don't want any exit times, all right? And I just want to make sure that my walk is looped. Yes, my run is looped and my idle is looped. Okay, everything is great. That's all we're going to need in here. That's all we're going to need in here for now. I'm going to save that off. I'm going to save off my project, File, Save Scene. And now we're going to start taking a look at the actual code to be able to switch this stuff around. All right? Yep, that's what we're going to do next. Okay, so the code that we need is going to go on to the zombie detection node that we have set up right here. And all we're going to do, let's select it, and let's scroll down and say Add Component, and we're going to add a brand new script, and let's call it Zombie Controller. And the Zombie Controller is really going to be in charge of everything. Let's double click and open that up. It's really going to be in charge of everything that this zombie does, everything from scratch, all right? So everything from the direction the zombie's facing, to how long it's running, to the sounds it makes when it's idling, okay? So first of all, let's add in a bunch of variables in here. We're going to add a public game object, and we're going to call this the flip model. All right, and the flip model is going to basically be the part of the zombie that we're actually flipping back and forth. We're not going to flip the entire zombie. We're only going to flip a portion of it. We want the GUI and what have you to stay still, but we want parts of the zombie to flip back and forth in order to give us the different facing. All right, so that's the first thing we're going to set up right there, our flip model. The next thing we're going to set up is we're going to set up some audio options. So audio options, we'll call this audio options. All right, and the audio options are going to be pretty simplistic. First of all, we're going to have a public list of audio clips. Audio clip, and it's going to be an array. And we'll call this one here idle sounds. All right, so while the zombie is not running, we're going to allow it to make different sounds. So we're going to have a list of sounds, that it can go through, and it's going to choose one randomly as it goes through, as it waits for its idle. Next thing we're going to have is an idle sound time. So we'll have a public idle sound time set up. It'll be a public float, and we'll call it idle sound time. And basically, idle sound time is going to be how often this zombie can make an idle sound. All right. After that, let's have an audio source. We need a link to our audio source, and it doesn't say public. It can just be a private audio source, and we'll simply call it. We'll just call this zombie. Oops. We'll call it zombie. No, let's call it enemy movement. I'm spelling everything wrong. Movement. Oh my God. Movement. AS for audio source. All right, that's good. Now we're going to have when our next idle sound can possibly occur. So once again, we're going to call this float, and we're going to have it be a next idle sound. All right, and we'll set that equal to 0f for now, so it can occur immediately. It might happen immediately. After that, let's add in a public float, and this public float is going to be our detection time. So the amount of time that the player has to remain within the area of danger before it's actually detected. It might not be instantaneous. It might take a few seconds first. All right, before we actually start to walk. And that might give the character a chance to, like the player a chance to kind of jump in and jump out, depending on what it wants to do. All right, and we're going to have a float here that's going to be called start run. And that's going to be the time after it's been detected and after the zombie starts to walk. The start run is going to be when the zombie actually starts to run. All right, and we're going to have a bool in here we're going to call first detection. All right, and basically, like I said previously, the way I want these zombies to work is once you're detected, you're really going to remain detected. Now, you might not necessarily remain running the entire time. If you leave the danger zone, then you're going to kind of go back to being, you're still going to be detected, and the zombie will always be moving towards you, but sometimes it'll be moving at a run and sometimes at a walk. All right, now let's take a look at the, let's take a look at some of the movement options. All right, and some of the movement, we're going to need a couple of things here. We're going to need to know how fast this guy can run. So let's set up a public float, and we'll call it run speed. So that's how fast that our zombie can run. Now, obviously, if it doesn't always run, and sometimes it walks, we're going to need a public float, walk speed. And it's really going to be up to you if this is a different number, or you could set it up as some formula like a 1/2 of the run speed, or whatever you want to do. I'm going to set it up for 2 different values, so our walk and our runs might be 2 different values. Next thing we want to do is we're going to set up a public bool that we're going to call facing right, and we're going to set that equal to true to start off with. So what that means is whenever we put a zombie in the screen onto our scene, we don't generate these zombies. We're going to actually place them in the scene. You could set up a generator if you wanted to. I'm not going to bother, and not in this game anyway. I'm going to set up my maps the way I want. So I'm going to set up my zombies wherever I want them to be. When I put them in the scene, they're all going to be facing right. But afterwards, we're going to go through and we're going to set up code to determine if they should be facing right or left. And it's going to be randomized. It'll be all randomized. Next thing we have to know is the actual move speed. So public, no, we don't make this public, we'll make it float. We'll call it move speed. All right, and lastly, we're going to have a bool running. And this will be true if the zombie is actually running. All right, we're going to need a few more links here. We're going to need a link to our rigid body, and we will call this my RB, I guess, is perfectly fine. Let's make it a capital B just for funsies. My RB. And next we're going to need a link to the animator. So animator, and we'll call it my anim. That's a good name, my anim. And lastly, we're going to need the transform. We're going to try and find the transform of the player that we're trying to detect. So transform, and we'll call it detected. Oops, detected player. So when we actually go through and detect the player, we're going to save its transform in here, and we're going to use that transform to be able to determine where the player is in relation to the actual zombie, and be able to flip our zombie left or right wherever it needs to be faced. And the last thing we're going to need is a bool that we will call detected. And once the character is detected, this is going to be true, and it's going to remain true until someone is dead, either the zombie or the player. All right, let's go file, save, perfect. Okay, now what we need to do is set up a couple of our variables. Let's define some of our variables here. We're going to try and find my RB, which is going to be equal to our get component in parent, because we're not actually this is all taking place in the zombie detection area. It's not actually taking place on the top node. The top node is where our rigid body is. All right, so we're gonna have to go to our parent. So get component in parent, and we are looking for a rigid body. All right, great. Boom, 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 boom. Now we're also going to take a look for the animator itself, and once again, my anim is going to be equal to get component in parent, because once again, that's where our actual animator is located, right? So animator, boom, 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 boom. All right, there we go. And I don't know why animator is not turning blue. That's really bugging me. All right, so we're looking for the animator now. Great. And lastly, we're going to try and find the audio source. Now, the audio source, the audio source itself, we've got located on this node. All right, so what did we call that? We called it we called it, I think I called it enemy movement AS. I did. Enemy movement AS. All right, and that's going to be equal to get component. This is a very handy function. Get component, and we are looking for the audio source, the local audio source. Bam. All right, so that's pretty good. That's all the things like that we're going to need. We're going to want to set up a few other things here. Our running. Our running is going to be equal false to start off with. None of our zombies are actually running when we start off with. They're all just standing still. Detected. Detected is also going to equal false when we start, unless the player starts off within the actual danger zone. Then our detection is going to be false. Our detection is going to be false to start off with. Obviously, then first detection is also going to equal false. All right, first detection is false. Good. And lastly, move speed. And move speed, we're going to start it off equal to our walk speed. All right, and move speed is either going to be walk speed or run speed, depending. And it's going to change depending on, let's move this down so you guys can see it. It's going to change depending on what state everything is in. Let's add some space down here. All right, and one last thing we're going to do, we are going to determine the direction. So if, we're going to have an if statement here, and we're going to have a random direction that's facing, either left or right. And so this is going to be a random dot range, and basically what I want to do is have a value between 0 and 10, and if this value between 0 and 10 is greater than 5, then we're going to flip it. That's basically what we're going to do. So if it's greater than 5, let me put my bracket here, then we're going to flip, and we'll just call it flip. We'll make a function called flip, not flip model, just flip. All right. Flip. Now, obviously, we haven't written the flip script yet, so let's do that right now. We're going to go down here below the void update, and the flip script is going to be very, very simplistic. In fact, like I said, the zombie is not going to flip back and forth. The zombie is only going to flip once at the beginning. So right now, he's going to determine its facing, and after that, it'll remain facing that way until the character actually enters into the danger zone. And once the danger zone's been entered, then the zombie will flip to face the appropriate direction. So the flip function, void flip, and it's not going to take any parameters, and let's put our braces in. Great. All right, and now the flip function is pretty easy. It's going to take our facing right, and it's going to be equal to not facing right. All right, not facing right. And basically all that does is invert it. So if it was facing right, it was true, now it's going to be false. And if it was false, now it's going to be true. Now what we want to do is actually flip the model itself. All right, we're going to flip our zombie model itself. And we're going to do so exactly the same way we flip our player, by putting a negative value in the Z component of the scale. All right, so really, really easy to do. What we're going to do, we're going to take a vector 3, a new vector 3 basically, and we'll call it the scale. And we'll set that equal to our flip model. Is that what I call it? Flip? Yeah, flip model. Our flip model dot transform. So we're looking at the transform of it. And we're going to take a look at the local scale. All right, the local scale. And we're going to put that into our vector 3. And all we want to do is take the scale dot z, and we want to multiply the z by -1. That's all we want to do. All right, and then we want to put this back into our model, flip model. Dot transform. Oops. Dot transform. Dot local scale is going to be equal to the scale. All right. Bam. That's as easy as that is. We don't have to do anything else. That basically takes care of all the flipping that we need. Okay, so the next thing we want to do is determine whether or not our player has been detected, and that's easy to do. So we're going to go in here, and we're going to write a couple of functions here. We're going to write our void Ontriggerenter, and this takes one collider as its variable. Okay, Ontriggerenter. So what happens on Ontriggerenter? We want a couple things to happen. First of all, if it's the player, we want to make sure it's the player first of all. So if other dot tag equals quotations player, and that means it's our player. Great. And we also want to see and whether or not we've already been detected. So if we're not detected, then we want to do some stuff. Not detect dead. I don't know why it's not showing up. All right, if it is our player and we're not detected, then we want to do some stuff. So let's put in our braces and let's keep writing here. We want to immediately set our detected to be equal to true. Detected is going to be equal to true. All right, once we're detected, we are always detected. Next thing we want to do is we want to find out where our detected player is. So detected player, and this is just our transform, is going to be equal to other dot transform. All right, and that's all. We don't need anything else. We only need the transform. We already know we're looking at the player. We just have to know where the player is now. All right, so the next thing we want to do, we want to immediately start our animation, our detected animation. All right, we want to say our myAnim dot set bool, and which bool we want to set? I think we called it detected. Detected. Is that what I called it? Let's just make sure. Let's just make sure before we go too far here and we screw everything up. It's on here, and our animator, and it's called detected. Okay, great. All right, so detected quotations is going to be equal to detected. Why is it not showing up? Oh my god, detected. I'm actually making this video very late. I'm sorry guys, I've screwed up pretty big here. Alright, so we're going to set our bool to detected, and that way here we're going to move from our idle state into our walking state. Alright, now we want to check a couple of other things first of all. We want to check where the player is, because we're going to have to flip this enemy around to be facing towards our player. Alright, we want to do that for sure. So if there's two situations where we want to flip. If we're facing right and our player's on the left, we want to flip. And if we're facing left and our player's on the right, we want to flip. All right, just those two situations. So if other dot transform dot position dot x. We didn't have to do it this way here. Actually, we could have used detected player. Maybe we should. So we already have that set up. So let's do it. Detected, if detected player dot position dot x. All right, we can do it like that because we already have our transform and everything right here. So I can avoid a step here. So if our detected dot x is greater than our current transform, small t transform dot position dot x. So if our player's x is greater than, so it means it's to our right, and sorry, it's to our right, and we are facing right, then we want to flip. Am I doing this right? I'm doing this wrong. It should not be greater than. This should definitely be less than. And we are facing right. Then we want to flip. All right, so let's take a look what this is because I've messed up when I was saying it the first time. If our detected player's position in the x is less than our transform position on x and we are facing right, then we want to flip. And that's right. We want to flip. All right, great. Now, the other situation is else if our detected player dot position dot x is greater than our transform escape dot position dot x and we are not facing right. All right, so we're facing left. If that's the situation, then we want to once again flip. All right, those are the only two situations where we're going to want to actually flip our character around. All right, and that's it. That's our Ontriggerenter. Now we want to do something on our exit, so let's write that up too. Void Ontrigger exit. All right, and Ontrigger exit takes a collider as well. Collider, and we'll call it other again. Bam, bam, and bam. All right, so if it's our player, if our player is the one who's actually leaving, so if other dot tag equals quotations player quotations. Then what we want to do is we want to set our first detection equal to false. All right, so the player is no longer within range. We're going to set our first detection equal to false. We next want to say if we're running, so if we're actually running, then we're going to want to change that, all right? Because we don't want to be running anymore. We want to actually be walking. So if we're running, then my_anim, is that what I called it? Why is it saying not found? Anyway, my_anim dot set trigger, and the trigger we're going to set is our run trigger. That's what I called it, right? Yes, I did. I can see it right there. We're going to want to set our run trigger, and that's going to move us from wherever we were to wherever we're supposed to be. All right, so technically it's going to move us from running to walking. All right, we want to set our move speed equal to our walk speed. All right, so far so good. And lastly, our running is going to equal false. Okay, and let's close off our if statement, and let's close off our other if statement. And now I think we are all set. All right, let's file, save this. Great. Okay, so there's only one last thing that we're going to do for now. We're going to do some more code in this later on. We're going to actually go through it and set this up so that we've got ourselves a ragdoll death. But for now, we're not going to do that. We don't even have ragdoll set up yet. We'll probably do that in a few episodes from now. For now, though, we're going to change this from update to our fixed update, and let's get rid of this. Let's get rid of this because that's not true. And with fixed update, we want to do a couple of things. I'm using fixed update once again because this is actually a physics object, so I'm going to make sure that I am doing it on the physics step, that we're doing anything on the physics step. So let's go right here and we're going to say if we're detected. If detected. So if we're detected, we want to do a number of things here. First thing we want to do is make sure that we're facing in the right direction. All right, so if our detected, oh my god, detected player, our detected player dot position dot x, and you know what, it's basically exactly the same thing we had down here. So let's just grab this from down here. We want these two things. If detected player dot position we want these two things. Edit, copy. I'm just going to copy and paste this rather than type it all out. So basically, we want to make sure that we're facing the right way. All right? Same thing we did before. We just want to make sure that we are facing the right way. And that way, if our player jumps over, we can immediately, we'll immediately set ourselves up again. All right, so first thing we want to do is that. Now, if, after this, if it's not our first detection, then what we want to do is we want to start looking to see if we should be running. So we should set our start time, our start run. We're going to set our start run equal to time plus our detection time. All right. So we're gonna set our time to start running equal to our detection time. Let's actually add this in right now because it keeps giving me these errors and I can't stand seeing these errors. Oh, I'm missing this, that's why. Boom, boom, boom. There we go. All right, and after that, we also want to set our first detection equal to true. All right, so the first detection has now occurred. And we're about to start running here, all right? So now, let's go down here. We're going to add a couple of... missing my fixed update, aren't I? I'm missing this. There. That was screwed up too. All right, so coming out of the detected, this if here, the next thing we want to determine is if we are detected, again, detected, and amper, we are not facing right, We actually want to start the motion now. So we want to start moving in the right way. If we're not facing right, then what I want to do is set my velocity of my RB dot velocity equal to, it's going to be equal to a new vector 3. a new vector 3, and let's give it some values here. It's going to be equal to, in the x, it's going to be equal to our move speed times -1. All right, because we're moving in towards the left. All right, so we're going to go in the negative direction. All right, and bracket that. No, I lied. Yes, actually, I'm going to do this. I'm going to add another bracket in here. So we actually do this first. There we go. Order of operations. Now, comma. Now we need a y value, and our y value is going to simply be the velocity in the y. All right, my RB. We're not going to change it at all. Dot velocity. Dot y. All right, so we're not changing that at all. That's going to be controlled by gravity. We're not adding anything there. And lastly, in the z, we don't want anything at all. All right, let's close that off. Great. Now, else if we are detected, and we are facing right. We are facing right. Facing right. Then we want to have a new vector, myRB.velocity. Once again, I'm just going to grab this. I'm going to copy it, edit, copy, and I'm going to paste it right here. All right. So once again, myRB velocity is going to be equal to a new move speed, and instead of multiplying by anything this time, we don't need to. All right, and I'll dump this, and I'll dump this. All right, we're just going to do move speed. It's going to be also, once again, we're going to leave it as myRB of velocity in the y and 0. Once again, nothing in the z, and y is going to be handled by the actual gravity engine. All right, so far so good, by the actual physics engine. All right, so far so good. Now, if we are not running, and we are detected, and we are detected. All right, then what we want to do is we want to check and see if we should be running, because this is one lazy zombie and we want to get his butt moving. All right, so if start run is less than our time dot time, then what we want to do is we want to have our move speed change from walking to our run speed. All right, so our guy's gonna be running now. We want to set my anim dot. We want to set the trigger. Basically, what we want to do is go from our walk to our run. We want to set the trigger run. All right, and lastly, we want to set our running equal to true. Okay, and let's close off our if statement. Bam. All right, and a couple more things. We're going to add into this. One more thing, actually. What I want to add into here is the ability to make some idle or walking sounds. And basically, it's going to be simple. If we're not running, so if we're not running, then we can actually make these sounds. If we're not running, there's a chance we're going to make these sounds. All right, and let's add in our brace and our brace. All right, so if we're not running, and we're going to do an if here, and we're not necessarily going to make a noise. It's going to be kind of a random event. So we're going to do a random range. If our random dot range, and we're going to give it a, let's say, a 50% chance again. So between 0 and 10 is greater than 5. All right, so that's 50% chance. It's greater than 5. And our next idle sound, is less than time dot time, then bam bam bam, we are going to make a noise. Let's drag this down so you guys can see a little better. All right, let's add in our brace and return. All right, so if that's the case, then we're going to grab our audio clip. We're going to choose our audio clip. Temp. Let's just call this temp clip for now. Temp clip is going to be equal to our idle sounds. And remember, this is actually an array, so it's going to be our idle sounds. It's going to be an array, and it's going to be a random range. I like random range. Dot range, and it's going to be a value between 0, comma, and the length of our idle sounds. Idle sounds dot length. All right, and that's going to give us some value between those two. Close this off and semicolon. So that's going to give us something in there. And we're going to set our temp clip equal to that. Next thing we're going to do is we're going to set our enemy movement as dot audio, no, dot clip, excuse me, dot clip equal to our temp clip. All right, and with that being the case, we can now set our enemy movement as dot play, and it's going to play our temp clip, and it's going to be some random temporary clip. All right, and we're going to set our next idle sound equal to our idle sound time plus our time dot time. Okay, and I'm going to file save that as well. Perfect. Okay guys, I am back. I am sorry about that. I had a little girl who suddenly called daddy. Let me just save this, make sure everything is good. Files. Okay, it's already been saved. Perfect. And as long as we've got no issues here, console. Oh, we do have an issue. Line 69. Let's go check that out. Line 69. If running. Okay. I have a bracket in the wrong location. This should be if random range, and we should have between 0 and 10 is greater than 5. There we go. That should be good. File, save. And let's see if we still have this. Let's clear. Okay, good. All is good. All right, everyone. So everything looks like it's working here. Let's give it a shot. Now, let's go back to our scene for a minute. And I want to make sure that my player is outside of this detection zone to begin with. So I'm going to go to the top of my zombie. And I'm going to move it over so we're not actually in the detection zone. Let's move it right to there for now. And we're going to have to fill in some stuff here. Our zombie detection. Let's go down to this stuff here. First thing we're going to do, we're going to want to set up our actual zombie flipping. All right, so our flip model. Our flip model is going to be this master zombie. All right, we're going to grab this thing here and we're going to drag it and we're going to drop it into our flip model. Basically, what I did is I dragged in the rig, and the rig is going to drag everything else along with it. So that's perfect. So far, so good. The next thing we're going to fill in is we're going to have some idle sounds in here. And what we can do, let's go to our project. Let's go to our sounds. What did I call it? Audio. Let's go to our audio, and let's find the stuff I stole from Minecraft, which is zombie say 1, 2, and 3. I'm going to lock this so it doesn't move. I'm going to grab zombie say 1, 2, and 3, and I'm going to drag it and I'm going to drop it into idle sounds. All right, and bam, 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 we've got ourselves back into 3, an array of 3, and we've got ourselves here. I'm going to unlock it. Boop, like that. All right, so far so good. Now, how often do I want these idle sounds to take place? Let's say for now that once every, just for testing purposes, once every 4 seconds. All right, it'll be some random time around there. All right, and how long is our detection time? So let's give it a detection time of 2. And that's how long we're gonna walk before we actually run. And we'll set up a fairly large difference in our run speed and our walk speed. So let's make it, let's say 8.5 and 2. So the zombie's gonna really be moving as soon as he detects us. All right. So let's file save this. File save. And I'm currently, like I said, outside of that detection zone. Let's start this up. Now, first of all, our zombie is facing in one direction. All right, it's facing its direction, and it's currently in its idle, which is great. All right, now let's see what happens when I walk into detection zone. Zombie's walking towards me, and then he runs, and he gets me, and he killed me. All right, he's pretty fast. All right, so that worked like it was supposed to. Let's give that a try again. Let's hit play. This time the zombie is facing in the other direction, so when I step into the detection zone, it should flip around to face me. There he did, and he's walking. I'm going to get out of here. And that zombie is going to get stuck behind that fence, and that's perfect. If I leave the detection zone, he's going to again go through his simple walk state. I can't shoot him from here. If I leave it, he'll go back into the walk state. Let's go back and take a look. Out of the detection zone. Kill him. Grab that. All right, our zombie is working pretty darn good, if I do say so myself. The last thing we're going to do in today's episode, we're not going to take a look at ragdoll or anything like that for now. I'm going to go to my prefabs right here, and I'm going to drag and drop my zombie into the prefabs. Now, we're going to make some change to this zombie later on. He's not done, but now we can pretty much use him wherever we want, which is awesome. Let's go up here. Let's move this guy out of here for now. Let's put him over here. Give me a chance to go and fight him later. All right, let's move our heart pickup. Anyway, I'll do that later. File, save our scene. Guys, I hope you enjoyed that episode. We are moving along very, very well now. Oh, one thing I will show you. I did make a quick change to the actual drop that we made on this, and that was in our zombie death. So let's open that up. That was in zombie health. The drop itself was coming in slightly rotated before. Let's take a look at our zombie health script. Did I click on the wrong thing? Zombie health. And let's open it up. Here's our zombie health. I changed one thing from a previous episode. Whenever we had our drop previously, let's find out where that is. Add fire, make dead. Right here, we instantiate our drop. Instead of instantiating it with the rotation of the actual object that was dropping it, because our zombie has a 90-degree rotation when I put it in, because it had that 90-degree rotation, I actually just made it with a quaternion identity. All right, so if drops, instantiate the drop. Transform position is great, but we want it to be the quaternion identity, and that allows us to have a 0 rotation on our heart when we actually kill our zombie. Let's take a look and see. Let's just go over there and kill him. He's asking for it. All right, and there we go. Our heart is now facing in the right direction. All right, guys, I really hope you enjoyed that episode. If you did, let me know down below with a thumbs up. I like getting thumbs up, guys. Come on, let's be honest. Like, you know, tell me if I'm doing something wrong with a thumbs down, but really and truly, I like thumbs up. So give me thumbs up, give me lots of comments, and let me know how your game is going. I'm really very interested. All right, I really want to know if I'm helping you at all. Okay, guys, thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.